Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Hello everyone, in this video I want to talk about how we can write a series in summation or sigma notation. So first of all, what is a series? The series is just the sum of the terms of a sequence. So we've looked at sequences before in Algebra 1, even in Algebra 2. And so now we're just going to take the terms of the sequence and we're going to add them together, and that's going to give us our series. So we could have one of two types of series. We could have a finite series or an infinite series. So the difference is we're going to have an ellipsis at the end of our infinite series, meaning that it's going to continue on to infinity. And for finite, we are not going to have the ellipsis at the end. It's just going to end at our last term. So now in sigma or summation notation, notice we have the Greek symbol or the Greek letter sigma. So that's where the sigma notation comes into play. And notice on the top we have the amount of terms that we're going to include into our series. So for finite, notice we only had 1, 2, 3, and 4 terms. So that's why there's a 4 at the top. That is called our upper limit of summation. Now our lower limit of summation is going to be at the bottom of our sigma, and it's going to be I is equal to 1 in this case because we're starting with the first term. But we do have a couple notes over here on the side. The index of summation, it doesn't have to be the letter I. It could be whatever letter that the problem gives you. It could be K, it could be N, it doesn't matter. And it also doesn't have to begin at 1. So in this video, all of our series are going to begin with 1, but it doesn't necessarily have to begin with 1. And then over here we have 2I, and this is our rule of the sequence. So our rule of the sequence is what is happening to the position number as we plug it in for I. So if I look at actually both of my sequences here, 2, 4, 6, 8, whatever we plug in the position number, so the first term, we're going to multiply by 2, so the first term is 2. The second term, we would plug in 2 for I. 2 times 2 is 4, so the second term is 4. So down here we see kind of how we would read this, the sum of 2I. For values of I from 1 to 4. That's kind of the notation or how we would read what we see here in orange, which I just took from our example up here. So just to reiterate our vocabulary, the upper limit of summation is how many terms we're going to include in our series. The index of summation is whatever our letter is. Most of the time it's going to be I, could be N, K, really doesn't matter. Our lower limit of summation is the term that we're starting with, so the first term in most cases. And then whatever we see off to the right of our sigma is our rule of the sequence. Okay, so let's look at 4 examples here in this video, and let's see if we can write the series in summation or sigma notation. All right, so for example number 1, we have -1, 2, -3, 4, -5, and then notice we have plus ellipsis, but it ends with plus 40. So this is going to be a finite sequence, so whenever we write our sigma here, we're going to put 40 at the top, right? Because we have the first term, the second term, the third term, fourth term, fifth term, so on and so forth. So 40 would be the 40th term. So the series is going to end at 40. Now we're going to start with 1, so our index of summation and our lower limit will be 1. So now all we have left is to figure out what our rule for this sequence is. All right, so now we notice we have our numbers 1, 2, 3, 4, 5, all the way to 40, but we're alternating signs. So let's think about if we had the number -1, and what if we raised that number to the power of the position of the term? So for example, let's say we had -1, we raise it to the first power, and we would have a -1. Okay, now maybe it's just that. Well, let's look at the next one. -1 to the second power, and we get a positive, -1 to the second power, and we get a +1. Okay, well, for my second term, it's supposed to be a +2, right? So what can I do to 1 to make it become 2? Well, we could either add 1 or we could multiply by 2. So let's just try multiplying by 2, okay? So now let's say we had -1 to the third power. Well, that's going to give me -1, and now what could I do to -1 to make it become -3? Well, we'd multiply it by 3, right? So notice what our pattern is. If we multiplied our first term, which was -1, by 1, it's still going to be -1, right? And so now we have, this would be a -3. Now we have figured out our pattern, right? So we're going to take -1. We're going to raise it to I. Now I is just the position of the term that we're trying to find. And then we're going to multiply it by I. Okay, so for example, for the 40th term, let's say we have -1, raise it to the 40th power, and then we would multiply by 40. Okay, well, -1 to the 40th power, our degree, our power there of 40 is an even number, so that's going to be a +1, and then 1 times 40, and we do get 40. Okay, so our solution, or our final rule over here, would be what we've highlighted here in pink. We'll take that away because it doesn't really, we can't really see it very well. We'll just put a box around our final rule. Okay, so our upper limit would be 40, our lower limit is 1, and our rule would be -1 to the I times I. Okay. All right, number 2, we have 1 plus 1/4 plus 1/9 plus 1/16 plus, and then we see the ellipsis at the end. So we know this is going to be an infinite sequence. So we're going to put infinity on the top there for our upper limit, and our lower limit will let be 1. Now let's look at our pattern. This one may be a little bit easier to recognize. We have 1 and 1/4. So notice our denominators are simply perfect squares, right? We could write this as 1/1. So essentially what we're going to do is we're going to take 1 and we're going to divide it by I squared, right? So for example, we see the 4th term is 1/16. So that would be 1/4 squared, which is in fact 1/16. So our rule for this series would be upper limit of infinity, lower limit of 1, and our rule would be 1/I squared. All right, number 3. 7, 10, 13, 16, 19. We have 5 terms and it appears to end, right? So we're going to draw our sigma. We're going to put a 5 at the top and we're going to begin with 1. So 5 because we have 1, 2, 3, 4, and 5 terms. Okay, now let's look at our terms and see how we could arrive at these numbers. So how can I take my a number 1 and essentially make it become a 7? Okay, well, let's say I just added 6. Okay, well, 2 plus 6 is not 10, so it's not just adding 6, right? Okay, let's say I multiplied by 2 and then added 5. Okay, because 1 times 2 would be 2 and 2 plus 5 is 7. But 2 times 2 is 4 plus 5 is not 10, right? Okay, well, let's say we multiply by 3. So 1 times 3 is 6, and then we would add 1 to get, 1 times 3 is 3, and we would add 4 to get to 7, right? Okay. Well, 2 times 3 is 6. Do we add 4 to get to 10? We do. 3 times 3 is 9. Do we add 4 to get to 13? We do. 4 times 3 is 12, and we add 4 to get to 16, right? So I think we found our pattern. We're going to write this as 3I plus 4. Okay? So we take our term, the position of the term, we multiply by 3, and then we add 4. All right, and for our last one, number 4, 1/4 plus 2/5 plus 3/6 plus 4/7. And notice it does keep on going. So this is going to be an upper limit of infinity, and we're going to have our lower limit at 1. Okay, now at the top we just have 1, 2, 3, and 4, right? So I think for our numerator we could just write I. Okay, our first term we plug in a 1, second term we plug in a 2, third term a 3, so on and so forth, so we're good with I. Now across the bottom we just have 4, 5, 6, 7. So it's essentially like we're starting with our first term but increased by 3, right? So 1 plus 3, 2 plus 3, 3 plus 3, so on and so forth. So our denominator would just be I plus 3. Okay, and that would be our final rule for number 4, and that is how you can write a rule for sigma or summation notation.